So hello everyone, today in this audio class we will read the chapter number 13, Water or Oceans, from the book Fundamentals of Physical Geography, class 11 NCERT Geography textbook. So let's get started with chapter number 13, Water or Oceans. Can we think of life without water? It is said that water is life. Water is an essential component over the surface of the earth. The creatures on the earth are lucky that it is a water planet. Otherwise, we all would have no existence. Water is a rare commodity in our solar system. There is no water on the sun or anywhere else in the solar system. The earth fortunately has an abundant supply of water on this surface. Hence, our planet is called the blue planet. Next point is hydrological cycle. Water is a cyclic resource. It can be used and reused. Water also undergoes a cycle from the ocean to land and land to ocean. The hydrological cycle describes the movement of water in and above the earth. The water cycle has been working for billions of years and all the life on the earth depends on it. Next to air, water is the most important element required for the existence of life on earth. The distribution of water on earth is quite uneven. Many locations have plenty of water while others have very limited quantity. The hydrological cycle is the circulation of water within the Earth's hydrosphere in different forms, that is liquid, solid and gaseous phases. It also refers to the continuous exchange of water between the oceans, atmosphere, land surface and subsurface and the organisms. Next, the table number 13.1, components and processes of the water cycle. The components are water storage in oceans. The processes are evaporation, evapotranspiration, sublimation. Next is water in the atmosphere. The processes are condensation and precipitation. Next is water storage in ice and snow. The processes are snow melt runoff to streams. Next point is surface runoff. Next component is surface runoff. The processes are stream flow, freshwater storage, infiltration, groundwater storage, groundwater discharge, springs. So about 71% of the planetary water is found in the oceans. The remaining is held as fresh water in glaciers and ice caps. Groundwater sources, lakes, soil moisture, atmosphere, streams and within life. Nearby 59% of the water that falls on land returns to the atmosphere through evaporation from the oceans as well as from other places. The remainder runs off on the surface, infiltrates into the ground, or a part of it becomes glacier. It is to be noted that the renewable water on the earth is constant while the demand is increasing tremendously. This leads to a water crisis in different parts of the world, spatially and temporarily. The pollution of river waters has further aggravated the crisis. Now, can you intervene in improving the water quality and augmenting the available quantity of water? Next point is relief of the ocean floor. The oceans are confined to the great depressions of the Earth's outer layer. In this section, we shall see the nature of ocean basins of the Earth and their topography. The oceans, unlike the continents, merge so naturally into one another that it is hard to demarcate them. The geographers have divided the oceanic part of the earth into 5 oceans, namely the Pacific, the Atlantic, the Indian Southern Ocean, and Arctic. The various seas, bays, gulfs, and other inlets are parts of these 4 large oceans. A major portion of the ocean floor is found between 3 to 6 km below the sea level. The land under the waters of oceans, that is the ocean floor, exhibits complex and varied features as those observed over the land. The floors of the oceans are rugged with the world's largest mountain ranges, deepest trenches, and the largest plains. These features are formed, like those of the continents, by the factors of tectonic, volcanic, and depositional processes. Next point is divisions of the ocean floors. The ocean floors can be divided into 4 major divisions: the continental shelf, the continental slope, the deep sea plain, the oceanic deeps. Besides these divisions, there are also major and minor relief features in the ocean floors like ridges, hills, seamounts, gyres, trenches, canyons, etc. Next point is continental shelf. The continental shelf is the extended margin of each continent occupied by relatively shallow seas and gulfs. It is the shallowest part of the ocean, showing an average gradient of 1 degree or even less. The shelf typically ends at a very steep slope called the shelf break. The width of the continental shelves vary from one ocean to another. The average width of continental shelves is about 80 km. The shelves are almost absent or very narrow along some of the margins, like the coast of Chile, the west coast of Sumatra, etc. On the contrary, the Siberian shelf in the Arctic Ocean, the largest in the world, stretches to 1,500 km in width. The depth of the shelves also varies. It may be as shallow as 30 meters in some areas, while in some areas it is as deep as 600 meters. The continental shelves are covered with variable thicknesses of sediments brought down by rivers, glaciers, wind from the land, and distributed by waves and currents. Massive sedimentary deposits received over long time by the continental shelves become the source of fossil fuels. Next point is continental slope. The continental slope connects the continental shelf and the ocean basins. It begins where the bottom of the continental shelf sharply drops off into a steep slope. The gradient of the slope region varies between 200 to 3000 meters. The slope boundary indicates the end of the continents. Canyons and trenches are observed in this region. Next point is deep sea plain. Deep sea plains are gently sloping areas of the ocean basins. These are the flattest and smoothest regions of the world. The depths vary between 3000 to 6000 meters. These plains are covered with fine-grained sediments like clay and silt. Oceanic deeps or trenches. These are the deepest part of the oceans. The trenches are relatively steep-sided, narrow basins. They are some 3 to 5 kilometers deeper than the surrounding ocean floor. They occur at the bases of continental slopes and along island arcs and are associated with active volcanoes and strong earthquakes. That is why they are very significant in the study of plate movements. As many as 57 deeps have been explored so far, of which 32 are in the Pacific Ocean, 19 in the Atlantic Ocean and 6 in the Indian Ocean. Next point is minor relief features. Apart from the above mentioned major relief features of the ocean floor, some minor but significant features predominate in different parts of the oceans. First is mid-oceanic ridges. A mid-oceanic ridge is composed of two chains of mountains separated by a large depression. The mountain ranges can have peaks as high as 2500 meters and some even reach above the ocean surface. Iceland, a part of mid-Atlantic ridge, is an example. Next point is seamount. It is a mountain with pointed summits rising from the sea floor that does not reach the surface of the ocean. Seamounts are volcanic in origin. This can be 3000 to 4500 meters tall. The Emperor Seamount, an extension of the Hawaiian Islands in the Pacific Ocean, is a good example. Next point is submarine canyons. These are deep valleys, some comparable to the Grand Canyon of the Colorado River. They are sometimes found cutting across the continental shelves and slopes, often extending from the mouth of a large river. The Hudson Canyon is the best known submarine canyon in the world. Next point is Guyot. It is a flat-topped seamount. They show evidences of gradual subsidence through stages to become flat-topped submerged mountain. It is estimated that more than 10,000 seamounts and guyots exist in the Pacific Ocean alone. Next point is atoll. These are low islands found in the tropical oceans consisting of coral reefs surrounding a central depression. It may be a part of sea or lagoon or sometimes form enclosing a body of fresh, brackish or highly saline water. Next point is temperature of ocean waters. This section deals with the spatial and vertical variations of temperature in various oceans. Ocean waters get heated up by solar energy just as land. The process of heating and cooling of the oceanic water is slower than land. Next point is the factors affecting the temperature distribution. The factors which affect the distribution of temperature of ocean are: first is latitude. Just wait for a while. Just wait for a second. Next point is factors affecting temperature distribution. The factors which affect the distribution of temperature of ocean water are latitude. The temperature of surface water decreases from the equator towards the poles because the amount of insolation decreases poleward. Next is unequal distribution of land and water. The oceans in the northern hemisphere receive more heat due to their contact with larger extent of land than the oceans in the southern hemisphere. Next point is prevailing wind. The winds blowing from the land towards the oceans drive warm surface water away from the coast, resulting in the upwelling of cold water from below. It results into the longitudinal variation in the temperature. Contrary to this, the onshore winds pile up warm water near the coast and this raises the temperature. Next point is ocean currents. Warm ocean currents raise the temperature in cold areas, while the cold currents decrease the temperature in the warm ocean areas. Gulf Stream, that is a warm current, raises the temperature near the eastern coast of North America and the west coast of Europe, while the Labrador current, that is a cold current, lowers the temperature near the northeast coast of North America. All these factors influence the temperature of the ocean currents locally. The enclosed seas in the low latitudes record relatively higher temperature than the open seas, whereas the enclosed seas in the high latitudes have lower temperature than the open seas. Next point is horizontal and vertical distribution of temperature. The temperature depth profile for the ocean water shows how the temperature decreases with the increasing depth. The profile shows a boundary region between the surface waters of the ocean and the deeper layers. The boundary usually begins around 100 to 400 meters below the sea surface and extends several hundred of meters downward. This boundary region from where there is a rapid decrease of temperature is called the thermocline. About 90% of the total volume of water is found below the thermocline in the deep ocean. In this zone, temperatures approach 0 degree. The temperature structure of oceans over middle and lower latitudes can be described as a three-layer system from surface to the bottom. The first layer represents the top layer of warm oceanic water, and it is about 500 meters thick with temperatures ranging between 20 and 25 degrees Celsius. This layer within the tropical region is present throughout the year, but in mid-latitudes it develops only during summer. The second layer, called thermocline layer, lies below the first layer and is characterized by rapid decrease in temperature with increasing depth. The thermocline is 500 to 1000 meters thick. The third layer is very cold and extends up to the deep ocean floor. In the Arctic and Antarctic circles, the surface water temperature are close to 0 degrees Celsius, and so the temperature change with depth is very slight. Here only one layer of cold water exists, which extends from the surface to deep ocean floor. The average temperature of surface water of oceans is about 27 degrees Celsius, and it gradually decreases from the equator towards the poles. The rate of decrease of temperature with increasing latitude is generally 0.5 degrees Celsius per latitude. The average temperature is around 22 degrees Celsius at 20 degree latitudes, 14 degrees Celsius as 40 degree latitudes and 0 degree near poles. The oceans in the northern hemisphere record relatively higher temperature than in the southern hemisphere. The highest temperature is not recorded at equator but slightly towards north of it. The average annual temperatures for the northern and southern hemisphere are around 19 degrees Celsius and 16 degrees Celsius respectively. This variation is due to the unequal distribution of land and water in the northern and southern hemispheres. Figure 13.4 shows the spatial pattern of surface temperature of the oceans. It is a well-known fact that the maximum temperature of the ocean is always at the surface because they directly receive the heat from the sun and the heat is transmitted to the lower sections of the oceans through the process of convection. It results into decrease of temperature with the increasing depth. But the rate of decrease is not uniform throughout. The temperature falls very rapidly up to the depth of 200 meter and thereafter the rate of decrease of temperature is slowed down. Next point, the salinity of ocean waters. All waters in nature, whether rainwater or ocean water, contain dissolved mineral salts. Salinity is the term used to define the total content of dissolved salts in sea water. It is calculated as the amount of salt in gram dissolved in 1000 gram or 1 kg of sea water. It is usually expressed as parts per thousand or ppt. Salinity is an important property of sea water. Salinity of 24.7 parts per thousand has been considered as the upper limit to demarcate brackish water. Factors affecting ocean salinity are mentioned below. The salinity of water in the surface layer of oceans depend mainly on evaporation and precipitation. Surface salinity is greatly influenced in coastal regions by fresh water flow from rivers and in polar regions by the process of freezing and thawing. Wind also influences the salinity of an area by transferring water to the other areas. The ocean currents contribute to the salinity variations. Salinity, temperature and density of water are interrelated. Hence, any change in the temperature or density influences the salinity of water in an area. Highest salinity in water bodies: Lake Van in Turkey 330 parts per thousand, Dead Sea 238 parts per thousand and Great Salt Lake 220 parts per thousand. Next point is horizontal distribution of salinity. The salinity of for normal open ocean ranges between 33 parts per thousand and 37 parts per thousand. In the landlocked Red Sea, it is as high as 41 parts per thousand, while in the estuaries and in the Arctic, the salinity fluctuates from 0 to 35 parts per thousand seasonally. In hot and dry regions where the evaporation is high and the salinity sometimes reaches to 70 parts per thousand. The salinity variation in the Pacific Ocean is mainly due to its shape and larger areal extent. Salinity decreases from 30 parts per thousand to 35 parts per thousand to 31 parts per thousand on the western part of the northern hemisphere because of influx of melted water from the Arctic region. In the same way, after 15 degree to 20 degrees south is decreases to 33 parts per thousand. The average salinity of Atlantic Ocean is around 36 parts per thousand. The highest salinity is recorded between 15 degree and 20 degree latitudes. Maximum salinity, that is 37%, is observed between 20 degree north and 30 degree north and 20 degree west to 60 degree west. It gradually decreases towards the north. In North Sea, in spite of its location in higher latitudes, records higher salinity due to more saline water brought by the North Atlantic Drift. Baltic Sea records low salinity due to influx of river waters in large quantity. The Mediterranean Sea records higher salinity due to high evaporation. Salinity is, however, very low in Black Sea due to enormous freshwater influx by rivers. See the atlas to find out the rivers joining Black Sea. The average salinity of Indian Ocean is 35 parts per thousand. The low salinity trend is observed in Bay of Bengal due to influx of river water. On the contrary, the Arabian Sea shows higher salinity due to high evaporation and low influx of fresh water. Figure 13.5 shows the salinity of the world's oceans. Next point is vertical distribution of salinity. Salinity changes with depth, but the way it changes depends upon the location of the sea. Salinity at the surface increases by the loss of water due to ice or evaporation, or decreased by the input of fresh waters such as from the rivers. Salinity in depth is very much fixed because there is no way that water is lost or the salt is added. There is a marked difference in the salinity between the surface zones and the deep zones of oceans. The lower salinity water rests above the higher salinity dense water. Salinity generally increases with depth, and there is a distinct zone called halocline where salinity increases sharply. Other factors being constant, increasing salinity of seawater causes its density to increase. High salinity seawater generally sinks below the lower salinity water. This leads to stratification by salinity. So thank you for listening. This is for now. Keep listening for further audio classes. Thank you.